Hi, my name's Gabe. For this problem, we're asked to evaluate the definite integral of sine of 2x plus 1 divided by cosine of 2x from x equals 0 to x equals pi over 8. So as we're looking at our definite integral, in particular as we're looking at the integrand, we should see that this does not match with any of the forms that we are able to directly integrate. However, we do see that we have a fraction, and we can go ahead and split up the fraction and rewrite our integrand as sine of 2x divided by cosine of 2x plus 1 divided by cosine of 2x. In this form, it still might be a little tricky to evaluate the definite integral. However, we have a sine of 2x divided by a cosine of 2x, which is tangent of 2x, and we also have 1 divided by cosine of 2x, which you can rewrite as secant of 2x. So our definite integral becomes the integral from 0 to pi over 8 of tangent of 2x plus secant of 2x. It's at this point that we can go ahead and evaluate the antiderivative of tangent of 2x plus secant of 2x. The antiderivative of tangent of 2x will be negative 1/2 the natural log of the absolute value of cosine of 2x, and the antiderivative of secant of 2x will be positive 1/2 the natural log of the absolute value of secant of 2x plus tangent of 2x. It's at this point that we would like to evaluate our antiderivative from x equals 0 to x equals pi over 8. So we'll begin by substituting in pi over 8. This will leave us with a negative 1/2 the natural log of cosine of 2 times pi over 8, which is cosine of pi over 4, which we know is the square root of 2 divided by 2. Plus 1/2 times the natural log of the absolute value of secant of 2 times pi over 8, which is secant of pi over 4, which is the square root of 2, plus tangent of 2 times pi over 8, which is tangent of pi over 4, which is 1. Next, we'd like to subtract off what we have when we substitute in 0. So from here, we will have a minus negative 1/2 natural log of the absolute value of cosine of 0, which is 1, plus 1/2 times the natural log of the absolute value of secant of 0, which is also 1, plus tangent of 0, which is 0. So from here, we see that we have negative 1/2 natural log of the absolute value of the square root of 2 divided by 2, plus 1/2 times the natural log of the absolute value of the square root of 2 plus 1, minus negative 1/2 times the natural log of 1, which is 0, plus 1/2 times the natural log of 1, which is also 0. So at this point, we can think about our answer as being negative 1/2 times the natural log of the absolute value of the square root of 2 divided by 2, plus 1/2 times the natural log of the absolute value of the square root of 2 plus 1. From here, there are several different ways that we can go about simplifying this result. So let's go ahead and let's walk through one of the ways in which we can simplify our result. So first of all, what we see is that we have a negative 1/2 times the natural log of the absolute value of the square root of 2 divided by 2. We can imagine bringing this negative out in front of the 1/2 into the natural log as an exponent, which would allow us to rewrite negative 1/2 times the natural log of the square root of 2 divided by 2 as 1/2 times the natural log of the absolute value of the square root of 2. Since the square root of 2 is positive, we can just leave our result as 1/2 natural log of the square root of 2. And over here, we do have a plus 1/2 times the natural log of the absolute value of the square root of 2 plus 1. Since the square root of 2 is positive and 1 is positive, the absolute value of the square root of 2 plus 1 is just the square root of 2 plus 1. Now, at this point, we can go ahead and we can use the properties of logarithms to rewrite this as 1/2 times the natural log of the square root of 2 times the square root of 2 plus 1, which will be equal to 1/2 times the natural log. Square root of 2 times the square root of 2 is 2, plus the square root of 2 times 1 is the square root of 2. Finally, we can bring the 1/2 from out front inside of the natural log as the exponent of 1/2, or we can rewrite it as a radical symbol. So what we're left with is the natural log of the square root of 2 plus the square root of 2. And that is our final answer. Thank you.